Hello class, my name is Sarah and I'm going to be performing experiment 10 today with the calculation setup of the titration that we did from last lab, which was setting up a titration. This is the calculations portion. So first off, I'm going to show you how to calculate the volume of the titrant added. The titrant that we use, of course, was the sodium hydroxide. We're going to take the final burette reading. When we had it in the burette, it was 24 milliliters. And then the initial burette reading was 0, because that's where it started at in the burette. And that gave us, we just subtracted them and got 24 milliliters. So now to calculate the moles of sodium hydroxide, what we did was took the 24 milliliters and converted it to liters. And what we got was 0.024 liters. And then we multiplied it by the molarity of sodium hydroxide, which was 0.107 moles of it, and then divided by the 1 liter of the sodium hydroxide. And as you can see, we canceled out the liters, so what we're left with was moles of sodium hydroxide, and it's 0.003 after we rounded it and whatnot. Now, to calculate the moles of hydrochloric acid now, we take 0.024 liters, which was the 24 milliliters converted to liters. So it gives us 0.024 liters of sodium hydroxide. And we set up I just set up the equation right here, and it's 0.107 moles of sodium hydroxide divided by the 1 liter. And multiply the 1 to 1 mole ratio, which is 1 to 1, which is this is the equal number of moles at the stoichiometric equivalence point. So that's how you set it up here: 1 mole of hydrochloric acid divided by the 1 mole of sodium hydroxide. And that we canceled each of them out, and we're left with moles of hydrochloric acid, and that gave us 0.003 moles of hydrochloric acid. And if you can tell, the moles of NaOH, which is the sodium hydroxide, and the moles of the hydrochloric acid should be the same. Just like how the 1-to-1 moles are the same, that means that these have to be the same as well. I just written out the equation to show you. Now we're gonna do the calculation of the final molarity / the concentration of the hydrochloric acid. So now I set up the whole equation for you again, so I'm just gonna read it through. It's 0.024, which is from the 24 milliliters converted of sodium hydroxide, and the 0.107 moles of sodium hydroxide divided by the 1 liter, and then times it by the 1 to 1 mole ratio of hydrochloric acid over the sodium hydroxide, and multiply by 1 over 0.025 liters of hydrochloric acid. And what we get was, basically, it's supposed to be just the mole over the volume. So we got the moles of hydrochloric acid, which is 0.003 moles, over the volume of the hydrochloric acid, which is 0.025 liters. And when we divide them both up, it comes out to 0.12 molars of hydrochloric acid. The 25, by the way, was what was given to us at the beginning. That's how much was in it, in the burette. Now, to find the average, what we did was we took the final molarity, or the concentration of the hydrochloric acid, and we added them all up, because we did the 3 trials. And just to show you, we did 0.12 plus 0.12 plus 0.12, which gave us 0.36, and then we divided it by 3, and because of the 3 trials, and then what we got was 0.12 moles per liter. So that's how we do the volume of the titrant added, the moles, how to calculate the moles of sodium hydroxide, how to calculate the moles of hydrochloric acid, and how to find the final molarity / concentration and the average all together. Thank you. Have a good day.